and one of the founders of really big science. His grants, originally from the Carnegie Institution, if you transform them by inflation adjustment to modern dollars, millions of dollars, huge amounts of money. And because of that, he was able to do things other people couldn't do before, because he had lots of support for basically industrial science. I only want to look at a couple of these just for a minute. Founding Mount Wilson Observatory, of course, which was a major change from the way observatories worked before in technology, a major change in science and the kind of people that worked. And in particular, California Institute of Technology, which you see down here in the bottom of this list. The Troop Institute people wanted to make their school bigger. And when Hale got here, he was already famous. So they put him on a committee and he created Caltech, but he was kind of a Renaissance man. So he wasn't just a physicist and a scientist. It was a scientist, of course, but not just a physicist and astronomer. Caltech became the leading school it is today because of George Ellery Hale. And even Thomas, geneticists in the world, he came to create the School of Biology at Caltech because George Ellery Hale explicitly invited him to come. And so this was a very big deal. So all these things are a huge list of accomplishments. And you have to wonder, where does a guy come from who can do that? So what you see here is a picture of George as a kid. And in the late 1800s, early 1900s, there were a lot, it's a big market for books, guidebooks that would teach boys all the things they got to do to be men, and teach girls all the things they got to do to be women. Very popular these days. I don't think you see much of those. But this is a page from one of George Ellery Hale's books, How to Build a Simple Spectroscope. When he was a little kid, he built a spectroscope. He was fascinated by spectroscopy. His father built a machine shop for him. He could do experiments, build things, and his father would buy stuff for him that he needed only after little George wrote a proposal to explain why he needed and what he was going to do with it. So he learned how to do that at a very early age. So you learn the mechanics of how to get money from people, how to convince people that you know what you're talking about, how to actually make things himself. And so he was able to accomplish all these things because he had so much technical schooling so early. But there's another side of a personality that you need to make accomplishments like on his list. Those are not things one person does. Those are team accomplishments. You need other people working with you, and you need to convince them that what you want to do is what they want to do also. And that's how you become highly successful. Now, the fellow on the right here, John Brashear, telescope maker, one of the most famous in America, right up there with Alvin Clark. And we have a Brashear telescope at Mount Wilson. That's what you see pictured here. That's the 6-inch Brashear on a Warner and Swayze mount that's in the clamshell dome right next to the 60-inch telescope. It's been completely refurbished, works great. George Hale got a lot of stuff from Brashear, and we even have some up at the observatory. He had commenced a correspondence with Brashear, who figured that he was probably around 40, 45, middle-aged guy, obviously an experienced and expert astronomer. Why haven't I heard about this guy? Because his name's not in any of the books. This is crazy. He knows what he's talking about. Nobody knows who he is. So Hale showed up at Brashear's shop in Pittsburgh. And when Brashear saw this 20-year-old kid walk in the door, he'd go, oh, okay, there's some kid looking for a job. Now what am I going to do? And when he says, I'm Mr. Hale from Chicago, he's like, oh, that can't be. How can you? And he remarked in his memoirs, I took a liking to the fellow at once. And if he had been a lady, I should like to have proposed. But he wasn't, and I was married anyway. So there's a little late 19th century prose for you describing the fact that Hale had a wonderful personality, easy to get along with, a team maker, and combine that with his technical and scientific abilities and a drive to do things is how he managed to accomplish so much. Now I'm going to come back to George and kind of bring him back down to earth when I get finished. But the next thing I want to talk about is the Snow Solar Telescope, named by Helen Snow for her father. George had begun looking at the sun when he was a little kid, so he's fascinated by solar physics. It's pretty hard for astronomers not to notice the sun, and so they knew there. But then when they looked at it, or they did precision timing to determine when solar noon was, because time zones didn't exist back then. Every town kept their own time, however they felt like doing it. And so they needed to watch the sun to figure out the time. But Hale did something remarkably different. He decided he would study the physics of the sun. In order to do that, he needed a specialized telescope designed just to look at the sun. So if you can see my little arrow, I hope, there's a mirror on the bottom. The light comes down, hits that mirror, bounces off the upper mirror, and then flies across down a shaft. And I'll show you what that looks like in a few minutes. It was paid for by Helen Snow in 1903 with $10,000, which translates into approximately $300,000 in 2020 money. So there's a lot of money. So the snow came to Mount Wilson. Here's a bunch of mules hauling it up Mount Wilson in 1904. Remember, cars didn't really show up till about 1903. So now cars, trucks, it's mules. Turns out that one of the mules in these mule trains, maybe one of the mules we're looking at here, had a peculiar attribute. Now, when you saw the image when you were in the waiting room of the galaxy, the NGC, whatever it was, because I can't remember, it was a spiral galaxy, that exposure took about 4 hours. And when you're doing something like that, the astronomer has to look through an eyepiece at crosshairs, put a guide star on the crosshairs, look at it, and sit there for 4 hours and adjust and tweak and get cold and freeze in order to make the image. Nowadays with digital and all that. Turns out one of the mules in this mule train had tail hair that was absolutely perfect for making crosshairs and eyepieces. So that mule was retired from mule train duty, lived the life of Riley down at Mule Camp in Pasadena, and donated its tail hair to science. Now, here's the snow being built on Mount Wilson. You can see the coelostat mirrors here on the upper right from another direction. Same thing, bottom mirror bounces the light to the top mirror, which sends it down the shaft. The construction over on the left, the section that's in front of the main building slides and the coelostat mirrors go on this pier. This slides over and protects the mirrors when you're not observing, slides back and exposes them when you are. And when the light goes down this shaft, is what you see. If you're looking down the shaft, there's a parabolic mirror down at the bottom. That mirror sends the light right back to where the photographer is standing when he took this picture. So you'd be standing in the way, blocking the sun, or else you get vaporized by the sunlight, something like that. So bad spot to be in. I'm going to explain what happens to that light in a few minutes when it comes off that parabolic mirror, but it comes right back towards the photographer. The long horizontal building is the Snow telescope. Here's that part that slides to reveal the mirrors when you're observing. Finished in 1904, started doing science in 1905. 60-foot tower on the right, 150-foot tower on the left, which finally started working right in 1912. That's why Mount Wilson Observatory was originally called Mount Wilson Solar Observatory, and it didn't change its name until 1917 when the 100-inch telescope went online. Then it became just plain Mount Wilson Observatory. Prior to that, it was Mount Wilson Solar Observatory. So who cares about this telescope? Well, these images are the very first hydrogen alpha images ever made of the sun. And some of you out there watching are probably solar observers. You have your own solar telescope. You have a hydrogen alpha filter on it. this is where it all started. At Kenwood, his own personal observatory, and at Yerkes, Hale had observed the sun in calcium light and in other house hydrogen lines, gamma, delta, beta, but all blue, and not much shows up. But in hydrogen alpha light, an amazing array of features shows up on the sun that had never been seen before. Very exciting. Hale saw features in these images that reminded him of magnetic fields. He went looking for magnetic fields and found them, which was a big breakthrough. He also used this telescope spectroscopically to prove that sunspots are dark because they're relatively cool, which seems intuitively obvious today, but was not at all obvious in 1906, 1907, 1908 when he was doing that work. He used the telescope spectroscopically, and here is a picture of the spectrum. Now, we use the Snow Solar Telescope today. In fact, it's just been refurbished. It's in grand condition. It's all been derusted, repainted, looks like brand new. And we use it for our STEM programs where we teach spectroscopy to grade school and high school students. And what we do is project the spectrum of the sun onto frosted glass so you can see it very clearly. And you can walk up to it and just look at it, kind of the way George Ellery Hale looked at the solar spectrum. When he was a kid, he just projected and looked at it from his little spectrometer. That's what we do, only we have a much bigger spectrometer than he had. And that's what this is. It's a photograph of a section of that frosted glass plate that shows the sodium doublet line. And you can see this is a pretty good spectroscope because those are only a few angstrom units apart, but the lines are very clearly separated. It's a very good spectroscope. And in fact, last month, we had our first STEM session of the pandemic season after getting everybody vaccinated and going through all kinds of health hoops to make sure everything was safe. And this is Chris Burns, a Carnegie astronomer, standing on the right. And if Chris is out there in the crowd somewhere, yo, Chris. And that's me holding up a peculiar periodic table of the elements, which is not like the one you see in chemistry class. It shows the individual emission spectrum of each element. And by looking at the spectra, you can determine what the element is that you're looking at. And when you get a whole bunch of elements together like the sun, you got to do a little work to separate them. But yeah, you can actually do it, figure out what the sun is made out of. So we let them do that. The students identify individual elements, and then they look at the spectrum of the sun. Now, remember that picture I showed you just a few minutes ago where you're looking down the shaft and you see the curved mirror down there and the light's coming right back to the photographer. Well, that point of view was from up here on this deck. And here is a mirror right up at the top of the image, which has the light reflected off of it from the main mirror. That light goes down, straight down from that mirror into a pit, hits the spectral grating, spreads out the light, shines on the frosted glass. And the students just walk up to that spot and look at the spectrum so they can see it with their own eyeballs. Yes, the sun actually does that. It's a really good program, in my opinion. If you want to find out about it, you can look at the Mount Wilson Observatory webpage, and then there's a link on there that goes to all the STEM programs. So the last thing I want to do is go back to George Ellery Hale, who has an enormous legacy and reputation. And sometimes what happens when people have reputations like that is they become what historians call a marble man, who can do no wrong, a statue in the middle of town honoring his enormous accomplishments. But you have to remember that while George Ellery Hale was a brilliant scientist, fantastic at getting things done, he was also a guy, just a guy, who in fact rode a motorcycle. And in 1908, while riding a motorcycle in downtown Pasadena, a couple of guys came up to him on their motorcycles and he decided they wanted to race. So he leaned over his handlebars, hit the gas, and took off. and they came after him because they were the brand new motorcycle cops from the Pasadena Police Department, and they nailed him for going 45 miles an hour, which was a breakneck speed in 1908. Okay, today, yeah, you walk 45 miles an hour, but in those days, and they fined him $10, which inflation adjusts to about $300 by today's standards. So it was a reasonable fine. And so George was also an ordinary person. And I know they still do this around Caltech because my graduate advisor was a student at Caltech until Caltech asked him to pursue his degree somewhere else because they were tired of how many times he was running away from the Pasadena Police Department in his hot rod. So I know they still do that. There's a sport in Pasadena, running away from the cops if you're a Caltech guy, or hopefully not a Mount Wilson guy, because, right? So with that, I've told you what I meant to say about George and what I meant to say about the Snow Solar Telescope. And I'm going to open it up to questions, and they're going to funnel me questions, and I'm going to answer. Heavens to Murgatroyd. Now I have to stop.
That was fabulous, Tim. Thank you so much. And again, if you have questions, please put them in the chat. We have gotten a few of them. That was so interesting and fascinating. And one of the things I liked the best about this, Tim, was seeing kids up there, because we want kids to understand and appreciate what Mount Wilson was all about. I remember going up as a child. My dad took me up there, and learning and getting excited about everything that's going on up there. And so to think that, you know, over 100 years ago, this place was started, and today are learning about it, and it's fantastic. So love seeing those pictures. One of the questions that came in was on the Snow Telescope. Was that was Helen physics or her father, or was it just Hale was such a great, you know, so persuasive that he was able to talk her into donating the money?
As far as I know, neither her nor her father were connected to astronomy or astrophysics. She wanted to honor her father's memory, and that was a good way to do it. And whether she came up with the idea or whether George knew she was susceptible to suggestion, I don't know. But he was, of course, not beyond that. If he thought you had money that he could get his hands on, he would find a way to do it. Quite skilled along those lines. So which way that went, I really don't know.
It is interesting how scientists today have to be scientists and almost entrepreneurs of getting money from people to further science and investigation, and we all want to help on that. I had a question, actually. Did he travel up the mountain on his motorcycle, maybe away from the little old lady from Pasadena, or did he travel in you know, in a car when he went up?
I don't know whether he went up there on his motorcycle. When he went up there the first time in 1903 and again in 1904, I'm pretty sure he rode horses up the mountain. And I think it was the very first car to go up the mountain. And I have a picture of it somewhere. I can't remember the date. It's like 1907, maybe, something like that. I can't remember. But it was a few years before any cars went up the mountains. Because remember, in those days, climbing a little hill in one of those cars would really wind you out. But climbing up to Mount Wilson, cars and trucks just weren't quite up to that.
Crazy. And I see a question in the chat, and someone answered it in the chat, of when were the roads built up there? And someone has answered that the trail was built in 1906, 1907, and the roads in 1930. So it was a trail for a long time, it sounds like.
Yeah, I think the road, Mount Wilson Road from Angeles Crest wasn't completed until 1935. Wow. And so until then, it's the Mount Wilson Toll Road, that first road, which was, it's actually already existed when Hale went up there in 1903, but it was a trail, really. So it got widened in 1906, 1907, so that big stuff could go up. Before that, it was like a mule trail. And Wilson Toll Road Company owned the land the observatory wound up sitting on, and so the owners of the toll road company got to go up the mountain with famous people. Otherwise, nobody would know.
Mind blowing to think of bringing a mirror and all of that equipment up a trail with a mule 120 years ago. Crazy. Question from the audience: did they have Ha filters then? I don't know what that means. Do you?
It means H alpha. They did not have H alpha filters. What they did was use one of Hale's many spectacular inventions called the Spectrohelioscope, and it was a device that permitted you to image the sun, or anything else for that matter, but they use it on the sun, in a single wavelength of the spectrum. So you could pick out hydrogen alpha lights. I only want to see that. And it would take that line off the spectrum and feed it to a device and move that over the glass plate so that you would get nothing but hydrogen alpha light on it. It was complicated, and you can see some artifacts in the image from the motion of the machine that moves the light over the photographic plate. And remember, they were using glass plates with photographic emulsions on them, and the photographic emulsions worked pretty well at blue light, which Hale was using at Kenwood and Yerkes, but not so well at red light. It wasn't until they got really good red light sensitive emulsions that they could make hydrogen alpha images of the sun and discover all the spectacular details that were there that opened up a whole new branch, really, of solar physics. You learn a great deal more from the hydrogen alpha than from the calcium.
That is amazing. Question is, how did Hale select Mount Wilson as a place in the whole United States?
Good question. Well, you may be familiar with Lick Observatory up near San Jose. And when they were building Lick Observatory, they checked out Mount Wilson and realized that it was a good place to put an observatory. But James Lick, who was paying for the telescope and had been talked out of building a giant statue memorializing himself in order to build the telescope, said, it's got to be where I can see it out my bedroom window. And so it's on Mount Hamilton up above San Jose, because that's where the guy paying for it wanted it to go. George Hale, after he graduated from MIT in 1890, was at Harvard College Observatory, 1890-91, and they sent a telescope out here to test Mount Wilson as a joint venture between USC and Harvard. But the USC money fell through, and I don't know if the Harvard people really liked all the rattlesnakes at Mount Wilson. Anyway, so that process fell through, and the glass they were going to use for the telescope went to Yerkes for the 40-inch refractor. So Hale was already familiar with Mount Wilson, knew it was a good site, and went out here to test it. And indeed, the seeing is very good. But he was also concerned because he wanted to build a really big observatory, not like the little ones. He wanted a big thing. And he wanted to build it close to Los Angeles because it's a major seaport and a major rail hub. So he could get lots of big stuff to his doorstep without too much trouble. And so all that combined, the expert seeing plus all the support that he gets industrially from Los Angeles was what made him choose Mount Wilson. But I suspect the clarity and steadiness of the sky was the number one concern.
And even today, now that there's so much light in Los Angeles, I would assume best viewing is when there's a layer of clouds that's between the city and the observatory. That
is indeed true. We're supposed to call it June gloom, but this June we didn't get much gloom. Pretty sunny. May gray, we got a reasonable amount of that. Yes, the best seeing now is when you can shut down the lights of the city with a cloud layer, but light pollution has no effect at all on the near infrared wavelengths. And the Georgia State University Center for High Angular Resolution Astronomy, the CHARA interferometer, does most of their observing in the near infrared, where the light pollution is invisible. And it's the steadiness of the skies and the existing infrastructure. It's one of the reasons, primary reasons, that they put their facility, which is the largest in the world. Everything that went up to Mount Wilson was the largest in the world at the time, except the 6-inch Brashear, which was not the largest in the world. Otherwise, yes, we have a habit of having the largest instruments of the world at Mount Wilson, and we are not inclined to break that habit at any time in the near future.
And that CHARA is still, research is still being conducted today?
Oh, yes, yes. It's the only instrument in the world that can map the distribution of brightness across the surface of a star, see hot spots, cold spots, and map out the shape of a star. So they can do a great deal of fascinating stellar astrophysics. And it's a busy place. Everybody wants to go there. Everybody wants to go to Mount Wilson. I don't know why.
And tell us a little bit about where you are right now and who that is over your right shoulder.
I am sitting in the library at the Carnegie Observatory in Pasadena. And up here is a portrait of George Ellery Hale. And you can see the bound books all around me, which are bound collections of the Astrophysical Journal, which Hale started, Astronomy and Astrophysics, a number of monthly notices of the Royal Astronomical Society, a number of publications. So this is the library and the reading room of the library. There's other parts of the library that, I can hardly fit in. At Carnegie Observatories in Pasadena. Mount Wilson was the very first Carnegie Observatory. Carnegie Institution in Washington owns Mount Wilson Observatory and holds the lease from the Forest Service, which owns the land, but it's the Mount Wilson Institute that manages, operates, funds, and controls the observatory. And so, yes, we do have multiple layers of administration, which occasionally require paperwork delays. But so far, everybody seems to be getting along with each other, and we get the jobs done when they need to be done.
And the mountain is currently staffed as well, is that right?
Yes, and it's open again. That STEM class I showed you in my talk, 5th and 6th grade students, was our first of the season. And we're kind of open for business again along. At some point, the concerts and lectures will start again, but I don't know the schedules for that. But the grounds are open and you can go up there and look around. And when the tours will start, I'm not sure about that yet either. The Cosmic Cafe is open on the weekend, so you can go up there, get a sandwich.
A question about power generation. How was it powered back in the early 1900s?
Well, there is a generator on the mountain that the one we have now was built in 1911. It replaced an earlier one, Fairbanks Morse. It was originally designed to run on something called California distillate, which was some weird concoction of flammable stuff that I'm not altogether sure what it is, but we run on normal gasoline now. It's been completely refurbished by a team of retired mechanical engineers who love old engines, and it works. It's two big pistons and runs, I think, on a 4-stroke, makes lots of noise. They would power that up and charge a building full of lead acid batteries during the day, and then they would turn it off, and at night they would run the observatory off battery power completely. And they didn't want to run the generator at night, partly because it shakes the ground, and you can see that. There's a Caltech seismometer right outside the building, and when you turn on the generator, you can see the Caltech seismometer wiggle like we're having an earthquake or something. And also because it spits out hot air, and the hot air rising is going to mess up the seeing. So you want that to be shut down at night. So you run it on DC battery power. The domes and some of the equipment still run on DC, but our power now is Southern California Edison AC, so we have to rectify it back to DC in order to make some of the DC components work. But that generator works, and it was water cooled, and the hot water went to a shower that was built right next to the generator. So you could actually, before they dumped the cooling water, it would be hot because it just ran through the generator. You could take a hot shower without having to worry about heating extra water. So
that's amazing. That's amazing. Question from the audience. Do you know if Chara was used to observe Betelgeuse during its dimming last year?
I do know, as a matter of fact, that Chara was not used, and in fact cannot be used to look at Betelgeuse. And the reason Chara cannot look at Betelgeuse is too big. The baselines for the interferometer are not small enough, so they can't get a closure phase and actually look at Betelgeuse because it's just too big. You can see Betelgeuse with the Hubble Space Telescope as a single disk, and it was observed in South America, the European Southern Observatory, very large telescope interferometer, which does have baselines short enough because it's smaller than Chara, just thought I'd mention that, does have baselines short enough, and they were able to look and determine pretty much what the real. It's nice to have what you would expect confirmed.
Okay. Another question.
Okay.
Are images of the sun still collected on the solar telescopes up at Mount Wilson today?
Yes. We don't do the kind of research we could before. The computer that controlled the scientific equipment in the 150-foot solar tower no longer functions, so we can't use that. But the solar observer, Steve Padilla, who's been there even longer than I have, still makes his drawing. He projects the sun onto a piece of paper, and he carefully sketches what he sees. And he produces a tracing of the sun every day. He looks by eye at the spectrum to record the magnetic field strength and annotates his drawing and posts it. They've all been digitized now, all the way back to 1917, drawn in the same way, same kind of equipment. And he posts that to his webpage, the solar tower webpage, every day when weather permits or when his health permits. And the 60-foot tower is still being used by a helioseismology program from USC that Ed Rhodes runs. And they still go up there occasionally and observe with that and look at the wiggles of the sun.
So essentially we have, go ahead.
Well, helioseismology, which is cutting edge science for diagnosing the real-time interior state of the sun, was discovered at Mount Wilson Observatory using the 60-foot solar tower and 150-foot solar tower, but mostly the 60-foot. And it is today at the forefront of solar science. And it's just every science that you can think of in astronomy, astrophysics, technology, everything you can think of about it. It was either invented at Mount Wilson or we fixed what was wrong before, one way or another.
Unreal. And I was just going to say, to think that, you know, there's virtually 100 years of everyday collection of sunspots is another mind-blowing thing to think about in 2021. So,
yeah.
Question from the audience: did David Darling invent the coleostat? I'm probably not saying it.
I don't know who invented the coelostat, but that's it's late 1800s technology. But I don't know who the inventor was. But I know there's a David Darling website that probably has nothing at all to do with it.
And I think that's it for the day. All the questions have come in. Thank you so much, Tim, and thank you all for being with us today. We hope that you'll join us for the next Sundays with Tim on Sunday, July 25th, again at 5 p.m. Please mark your calendars for the last Sunday of the month through September. We'd love to see you again. Prior to that, Chapter 3 of Discovering Mount Wilson will be posted on our social media platforms in 2 days. And so that's going to be this Tuesday morning, June 29th. Chapter 3 will go into a little bit more detail about the solar telescope. So we hope that you log on and view that. And thank you again, and we'll see you in July.
Thank you. Very good.
Thank you, Tim.
Thank you. Thanks for listening.
Thanks, Tim.
Always good to listen.
Thanks for not falling asleep.
Very interesting.
People fall asleep at talks all the time. But as my brother once said, falling asleep during the talk is not a big deal. It's falling out of your chair that really gets you in trouble.
Well, then we'll all be dreaming about Mount Wilson tonight, I'm sure.
Good. Are we all
Hey,
done?
Tim, do you think you might be able
Looks
to
like
make it up to the LAAS 60-inch night on next Saturday?
I don't know. It's probably not a good idea for me to drive up the mountain. I can drive here. Trying to drive up the mountain might not be a good idea for me. But
Okay.
I'm walking around better these days, so it would be nice if I could.
Want me to come pick you up and drop you off?
That might be necessary, but we'll wait and see what kind of shape I'm in next weekend.
You just let me know. I can do that.
Okay, sounds good. Thanks.
And for the people who are left listening, there's still lots of openings for the LAAS 60-inch nights for all of the months other than the 3rd. So August, September, October, and November all have open spots.
Cool.
And I'll put my email address.
You just got muted, Tim. Or Daryl, sorry.
Yeah. Yeah.
Thank you.
Tim, that was so funny about him getting a ticket for speeding on his motorcycle. You know, funny to think that the cops were doing that. I mean, you just, that's the kind of thing I guess I wasn't thinking about for what was going on in the 1900s around Pasadena.
It was brand new. The Pasadena police didn't have any, they were all horse mounted, right? Didn't have any motorcycle cops. But then when the cars came out, they put some in cars and then they put some on motorcycles. And George didn't know, I guess, and didn't recognize them. I was going up the mountain a few years ago during heavy fog with 2 motorcycles behind me and some incredibly impatient driver behind them who in the fog, when we got to a place where the road was a little bit fatter than it usually is, just took off around me and flew off into the fog at high speed, like a crazy person trying to get killed.
Ugh.
Turned out that the 2 motorcycles behind me were both county sheriffs. And they both went after him right where they had red lights and sirens going before he could get away from me. They were after him in a heartbeat. And I saw them later on. They had him over on the side of the road. Yet they nailed it.
Keeping us safe on the path up. Well, everybody, we do have to do a hard stop to jump out. So we are going to close the viewing. And again, we look forward to seeing everybody in a month. Thanks.
Cool.
Thank you. Thanks for doing this, guys. Appreciate it.
Thank you. Good night.
So long.